Well, hello there again, friends. Today is 9/16/2022, and today is the Odin Project vlog day 147. And I'm back with another video. We're on the project binary search tree balanced BST. This is part 3, and I completed the level order function, and in my case method, the inOrder, preOrder, and postOrder method as well. So I got number 6 done and number 7. So for the this video is probably going to go a little bit longer. I'm going to try not to, but in my head I'm kind of anticipating this is going to be a little bit longer video. So just giving you a forewarning there. For the brevity of this, I won't read you all this, but basically we're going to write a level order function which accepts another function as a parameter. Level order should traverse the tree in breadth first level order and provide each node as an argument. And they're basically saying you can implement this using either iteration or recursion, or trying both. And then you want to use an array to act as a queue to keep track of where you're at in the call stack. And so I decided to use iteration, good old-fashioned while loop. We'll go over in here in a minute. And then while I'm on this page, we'll briefly look at this. So then we're going to write 3 other, in my case, methods, since I'm inside of a class: inOrder, preOrder, and postOrder. And each of these functions traverse a tree at their respective depth first order and yields each node to the provided function given as an argument. And then the function should return an array of values if no function is given. So with that said, let's hit the editor. So here we are. Getting started here with level order. Root equals this.root to capture the current root. And just so you know, all of these down below here in the bottom of the code here, all these are called level order, inOrder, preOrder, postOrder, just like that, so that they are invoked for our tests. And there's no value placed inside them because we're on all of them we're retrieving the current root item, so there's no need to provide any input from the user. So level order, we have two arrays, one called queue and one called result, that are emptied, and just getting them set up locally for level order, for the level order method, that is. And so here we go. The first base case. Oh, I love it when that happens. Just kidding. All right. So first base case is right here. So if root equals null, we're going to return. So basically that means, as we went over in previous videos, we're at the bottom of the tree and there is no more values to be printed, so we're going to be printing null. Otherwise, we're going to continue on, and we're going to push root, whatever is in the current root, into queue. And just like in the text, we're going to use queue as a temporary storage place to run through our call stack, and then when we put our final result out there, it'll go in the result array. So that's why there's 2 arrays. So we're going to push that root value, current root value, in the queue, and then so we'll have a while loop here. So I'm going to iteratively loop through each root item. So if queue length is greater than 0, meaning there's something in the queue, we're going to let the current create a local variable called current, and it's going to take on queue.shiftRoot. So what shift does is it takes the first value in the array and removes it from the array. So in this case, we're calling root. So we're going to take root out of we're going to shift and take the root value of whatever it is out of queue, which is what we just pushed it in here. And then we're going to push current.data. So we're going to look to the current here, and whatever data value is inside of that, in our example numbers, we're going to push that to the result array, where it will reside there permanently, and that'll be what gets printed out. And then so there's a couple if statement conditionals here inside the while loop. We have an if current.left is not null, we're going to push queue current.left. So basically what that's saying is, so if our iterated item here, our iterated root value is not null, we're going to push that value to the queue. If it's the right side and it's not null, we're going to push that right side data to the queue. And then I put a console.log statement here to just print out the results, and we're going to return result. And so that's level order. And so this is what you end up getting. You get 4, 2, 6, 1, 5, 7, 8. I do not know why there is a space here. I'm guessing it's just a formatting thing. I don't believe my code's doing that, but necessarily. So anyway, just ignore that. So the values, just focus on the values. So if you remember in the breadth first approach, we're looking at the tree. I love this visualization. That's why I kept it up here so we can use it. The breadth first approach is going linearly. So imagine this is turn 90 degrees and you got your 4 sitting at the top here. I wish it was, but it's not. So just pretend with me that the 4, this is at the top. This is the highest position. So just rotate this up 90 degrees. And so how we're going to traverse through this, so we're going to evaluate 4. We're going to push 4 through the queue. And so this dot root, first one will be 4. 4 will come through. 4 will get pushed to the queue. And then it'll check the queue. It'll see it's not empty. And it's greater than 0. And then we're going to push 4 into the queue as current. And I'm sorry, we're going to shift 4 out of the queue and into current, and then we're going to use current.data, which will end up being 4, push it into result. And then we're going to evaluate 4. I'm not going to do this for every single one because this will take forever. I'm just going through one iteration of this for you to show you how it works. And then you have 4, so if current.left, so we're on the root node here, and technically this is null is our start. I can't even remember. It's not null. Whatever the beginning of roots are, I think it's start. But anyway, this is technically the right side. So we're going to go to the if statement for right. So if.right is not null because it's not. And this would not be evaluated as true because current.left is... I'm sorry. I got to get my left and rights right. Correct. This will evaluate... not true, it's false because we're not going down the right side, we're going down the left side here. So that won't be ran, but current.left does not equal null, which is true. There's a 4 sitting there. So that will then call this here. So we're going to push current.left into queue. So that's how we get 4 printed here. And so as we iteratively go and loop through this while loop, you're going to see we have 4 and we have 2. And then remember, we're not going to 1 because this is not depth first. That's for later. This is breadth first, so we're going horizontally across the tree. So we have 2, and then we have 6 because 6 is iterates back up through the call stack and goes down the right side and evaluates it. So 6 is applied, and then we go to 1. Because again we're evaluating this in breadth style, so the way the code works is then we shift over here back over to 2 again, and we do current dot left to get the value of 1, and then that gets printed, and then we'll get a return after this because the next item will be null. So then we'll return out, and then we'll go back up the call stack and go over here to 5. Actually, we'll reevaluate 6. 6 will loop iteratively through down to 5 on current.left, and we'll print current.left to 5, and then we'll do the same thing to 7 and the same thing to 8 because again we're going horizontally across. I'm probably not doing a very good job of explaining this. It's in the code. If you follow through the code like I just explained on 4, you'll see it play out. But horizontally breadth first approach algo is kind of hard to understand. It's not super easy, but anyway, yeah. So you get the 4, the 2, and the 6 because you're going horizontally, then you're going back down to 1, and then go horizontally to 5, 7, and then you go horizontally again at the last set of childs. There's nothing. It's null here, null, 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 and then 8 null. And so we're not printing nulls, so we're returning on nulls actually, but we will print the 8 at the end. So hope that kind of makes sense. I am going to move on though. I don't want to make this overly long. I will in-depth explain, like I just did with level order, I will in-depth explain inOrder, and then I'll just breeze through preOrder and postOrder because they're the same exact code, just inverted based on how you how you want to process it. So inOrder, we want to sequentially print the inOrder tree going from 1 to 8 in our example because we have a tree values from nodes from 1 to 8. So here we have I have this printing well, it's not it's recursively. If I said iteratively, I think I misspoke. It's doing this recursively. So anyway, that's why it's printing over and over and over just like last time. But anyway, we get 1 because we're gonna capture this dot root with the input variable here when we call it, and then we have if root equals, our base case is root equals null return. So we're gonna skip that, and then if root dot left does not equal null, we're going to take root dot left and apply it against this dot inOrder. So we're going to recursively go reapply inOrder and go over again and just loop through that over and over again. If root dot data is undefined, so basically once we finish left, we're going to go to undefined, and if root dot data is not undefined, we're going to push the root dot data into this dot inOrder data, and that is actually a an empty empty array that sits inside the class tree on the constructor. So here you have inOrder data here, and you have preOrder data and postOrder data. So all three of these have empty arrays up here, and these will house the contents. So it's in the constructor. So don't be confused if you see that and wonder where that came from, because that's where that goes. So it pushes into there, and then if that doesn't evaluate true, we have a if for this one, if root.right does not equal null, we're going to push root.right in this order and recursively go through the right side until it's complete. And then each time here, I have accounts.log, let's print this tree in order, as you see here. And then I went ahead and did a template literal here, so you could cleanly see this, because before I just had this dot inOrder data without it being in a template literal, and it looked like garbage because it had arrays all over the place and weird spacing, and this just came out a lot cleaner, so I just chose to do this for this demonstration purposes for the video. So that's how the inOrder works. So what it does here, so it's going to evaluate this dot root. So our first tree here item, so it's going to see 4, and it's going to excuse my Tourette's. It's going to have captured this dot root. It's going to look and see 4, and then it's going to see that it's root dot left, and so it's going to recursively go over that again, and it's going to look for root dot left. So it's going to process in 2, and then it's going to process in 1 in that same call stack. So as you can see, just in this easy example, there's no right childs on this branch, so we're only using the, we're just recursively going over root dot left. Oh, I hate that. Okay. So anyway, you'll hear a little bit of my stupid groan, but anyway, so this is how, that's how we have it in the call stack. So in the call stack, we have 4, 2, and 1 currently, and then we are going to hit a null. So when we hit a null, we're going to do a return statement. Gosh dang it, freaking night. I'm going to stop highlighting that because that just ain't worth it. Trying to keep you guys, keep you seeing where where my eyes are going. So anyway, goodness gracious. 4, 2, 1. So when we have these in the call stack, we have 4, 2, and 1. And then we hit null. So we hit null, we're going to return. And so when we return, that signals the recursive nature of the algorithm to call to. This is a LIFO, be last in, first out. So we're going to go up the call stack. The last in was 1, so we're going to print 1. Last in was 2. After that, so we're going to print 2. Last in is 4, so we're going to print that. And then after that, we've completed the call stack's empty. So now we're going to go over and do root.write. So if you see here, we're skipping down we didn't skip. We went through root.data. I just didn't cover it. They're not. None of them are undefined because they all have values. So those are all getting pushed. That's how the push is happening right here, and that's what you're seeing here. So now we're going to go over here to 6. And 6 is going to be evaluated with the root.write right here. Forgot to mute my phone. Sorry about that. Okay. All right. So so now we're over to 6. So now we're going to recursively go 6, and then we're going to go to 5. We're going to process 5 because we're going to go on the left side first. So we're going to process that. So we have 6 and 5 in the call stack, and then we're going to hit a null right here. So we're going to return out, and so we have 2 in the call stack, a 6 and a 5, and we're going to do LIFO. So we're going to go back through and process it LIFO. So we have 5 will be printed out with via the push. We're going to push 5, and then we're going to push 6. So that puts us right down here. So we have 5 and 6, and then we're going to do root.write. And again, this is opposite of the other side, so we're doing a recursion here down the root.write all the way down. No root.write, excuse me, no root.lefts on this one. So we do 6. We've already applied 6, so we're gonna put 7 in the call stack, and then put 8 in the call stack, and then we're gonna hit null because after 8 it's a null. And then we're going to LIFO out the call stack. So then we have actually, I goof on that one. 5, 6. No, actually, I goofed on that. We're going to do 7, and then it'll be the only one in the call stack because we're going to evaluate in this case, root.left. It will be null, and so we'll get a return, and then we'll call that call stack out. So that call stack will be printed out and pushed. So we have 7, and then we do back here, we come down and we do in order. We have root.left, which is going to be 8, and then root.write is null. And then we have the root.data is not undefined, so it's going to print and push that 8, and then we get a return at the null. So that's how that works. So the other two they call them functions. For me, they're methods because I'm inside of a class. Preorder and postOrder are the exact same functionality, the exact same fundamental thought. The code is really the same, it's just in a different order. So for whatever the need is. So here we have a preorder, so it wants us to go 4, 2, 1. So it wants us to go down, crawl down the tree in a breadth first approach. 4, 2, 1, 6, 5. 4, 2, 1, 6, 5. 4, 2, 1, 6, 5. 7, 8. So it's doing that. It's literally the exact same code. It's just flipped. So we always have our base case at the top, as we would always have for recursion. And then we have our undefined statement at the top because we want to catch that undefined quickly and early because it's a preorder. So we don't want it. We want it to push and print that file or that value as soon as possible and not hold it in the stack. So that's why that's there. And then if it passes that, we're gonna go to root.left and process it till null. Root.right, process it till null, and just recursively go through that. And that's how you get the 4, 2, 1, 6, 5. So in the tree style, you have 4, and then it recursively goes down the left side, 2, 1, and then prints those on the fly instead of call stacking them in reverse order, because we don't want to LIFO those like we did in the previous one. And then we're just simply crawling down the tree, and then we have 6 is processed on root.left, or excuse me, root.right. Man, my left and rights, I need to go back to grade school. 6, 5, and then we have 7 and then 8 on root.right. So, and root.left will always be will be null in this case. So when it hits the null, it'll return. So look at my code. I've sat here for a little bit, so you can look at my code, pause it if you need a little more guidance in that. I just don't want to make this video overly long, so we're already at 20 minutes, so I don't want to belabor this. And then postOrder is the exact same code. It's just, again, put in a different order. So again, we have our base case, which doesn't change, and then we have our root.left running first, because this is postOrder. So what we're trying to accomplish is going up the tree from the bottom up. So we have 1, 2, 5, 1, 2, 5, 1, 2, 5, 8, 7, 6, 4, 8, 7, 6, 4. So basically we're wanting to go up the tree, hitting up both left and right child nodes before we go to the next parent node before we complete. So basically it's opposite of the preorder. So instead of crawling down, we're crawling up. So instead of crawling down from the parent, we're crawling up from the child. And so we have our left side null statement here, and then we have our right side null statement here, and then we put the undefined at the bottom because we want to push it at the end on this case. So we want to basically put everything in the call stacks first, and then we want to read it back from the call stack, kind of like the similar fashion we did in inOrder. The first one I went through in depth. It's kind of like that. We were going to LIFO it and push it back to push the root.data of that LIFO stack back out to postOrder data. So I'm sure that was clear as mud. I went super fast, so please feel free to rewatch this for further understanding and cementing. Thank you for coming along the ride, and I hope you learned a little bit around these couple exercises here for BST. Thanks for coming along the journey today. Please like, share, and subscribe for more content, and let me know in the comments section how you guys are coming along with this very intense algorithm. I tell you, it's not easy. So, and so with all that said, until next time, see ya.